So finding factors of polynomials using synthetic division. All right. So we're going to use synthetic division, which we've been doing for a little while now, to check if certain values are actually, or if certain binomials are actually a factor of a bigger polynomial. Okay, so there's a couple ways to do this. We're going to use the factor theorem, which is part of the remainder theorem. So let me use a different color. And we talked about the remainder theorem, I think, last week. The remainder theorem says if we substitute in a value into a polynomial, it's the same as if we had divided it. Okay, so this factor theorem, in your book, it uses some equations, but basically, a polynomial f of x, some function, has a factor x minus k if and only if. So this is a special way to say this works both directions, this if and only if. F of k equals 0. So how is this useful? Well, if we do the synthetic division and we get 0 for our remainder, this is what this really means. That's the theorem. This is how we're going to use it. If we do synthetic division and the remainder is 0, then x minus k, whatever our divisor was, is a factor. And my picture's covering up some text, isn't it? Okay, so we're gonna have we're gonna have a polynomial, and we're just gonna check when I divide by this thing, do we get 0 at the end? Hopefully the answer is yes. It might be no. Now, some of the examples we're going to do right here at the beginning are factorable using other methods that are probably preferable to this, but we're just going to use it as an example for what we're trying to illustrate. So how does this work in practice? Well, is x minus 2 a factor of f of x equals x squared plus 2x minus 4? Is that a factor? Well, so what we do is we just do synthetic division using 2. And if we get 0 at the end, then it is. And if we don't, then it's not. So we get 1x squared, a 2x, and a minus a 4. So we just add down and then multiply diagonally to get our next addition problem. So 1 multiply by 2, get 2. Add down, we get 4. Multiply, we get 8. And then we get 4. In other words, This is not 0. So x minus 2 is not a factor of x squared plus 2x minus 4. This would be our true statement. So we're just checking, when we do our synthetic division, do we get a 0 at the end? And if we get a 0, that means that we can factor the function using this x minus 2, using the 2. Okay. So we're just going to do a bunch of these. We're going to do a bunch of synthetic division today. You can do this by dividing, and if there's no remainder, that means it's divisible too. But synthetic division is going to be way faster for most of the things we're doing, especially when we get larger polynomials like this one. Is x plus 5 a factor of 3x to the 4th, 15x cubed, minus x squared plus 25? So for our synthetic division, we set it up using the opposite here. Whatever number turns this into 0, that's the number we use. So it's negative 5. And then we use the coefficients. And if it skips a variable, then we need to use a 0. So it's 3x to the 4th, 15x cubed, negative 1x squared, 0x, and a 25. Okay, so I just use all the coefficients to set up my synthetic division. And don't forget the 0, because there's no x, it's 0x in our function. Okay, and then we're just going to add down and multiply across, and our goal is that this be 0. Yeah, I mean, we don't really have any control over it. We're just doing the synthetic division. So we're going to add down here. We get a 3 times negative 5 makes a negative 15. We add down and we get a 0. Multiply, we get 0. Add down, we get negative 1. Multiply, and we get 5. Add down, we get 5. 5 plus 0 makes 5. Multiply by the negative 5, we get negative 25, and so we get 0 at the end. This equals 0, which means therefore, 3 little dots means therefore, x plus 5 is a factor. If I can spell factor. Which means, what that means is, we can factor out x plus 5, and then all of these coefficients, all of this stuff here, is going to tell us what the rest of the polynomial would be. If we divide this by x plus 5, we get 3x cubed, 0x squared, minus an x plus 5 left. And if we were to multiply this back, if we multiply all this stuff, we should get what we started with. So we're just checking, is it a factor? And it's going to be a factor if our remainder is 0. And then we can write it this way. We can write the division there. Any questions so far? Any questions thus far? So we're just using synthetic division to check. Can I divide that thing? Yeah, so let's do another one. Uh-oh. Oh, I didn't get the mute off. I'm sorry. That was a really weird sneeze. Golly. Thanks. All right, so is x plus 4 a factor of 6x to the 4th minus 6x cubed minus 84x squared plus 144x? So there is a greatest common factor here that you could take out, but we're just going to go straight to the synthetic division. And so we'll have to see. I'm not sure this is going to work. So we're minus 4. Zeros where there's not a term. So 6x to the 4th is where we're starting. Minus 6x cubed minus 84x squared plus 144. Don't need the plus sign. And then 0, because there's no constant, so we need the 0. Is that right? Yeah, I guess so. Yeah, okay. So we're going to add down. So we get 6 times negative 4, negative 24, makes a negative 30. Seems rather large. Times negative 4 makes a 120. And so 120 minus an 84 is 36, I want to say. Times negative 4 gives me negative 144, which means we get 0. It means we multiply it, we get 0, and we get 0 here as well. So because we get 0 at the end, is equals 0, that means that x plus 4 is a factor. Should really be a question mark at the end of this problem. It is a factor. And what that means is, what we can do with that, and this is going to lead into more stuff next week. Why are we checking like this? Leads into x plus 4, and then we can write the rest of this problem as 1 degree less. So from x to the 4th to x to the 3rd, so 6x to the 3rd minus 30x squared plus a 36x. Now this does have a greatest common factor, right? We can divide everything here by 6, which if we were really factoring this fully, if we're completely factoring this problem, which we're going to do eventually, I would have done that at the very beginning. I would have divided all of these by 6x at the very beginning, and that would have made the rest of this have smaller numbers and be easier. But regardless, you're going to get a x plus 4 as one of the factors of this polynomial. Okay? Should we do another one? And if you have any questions, now's the time. Let me know. Let's do this one. We're going to get pretty good at it at synthetic division by the end of this chapter. So from here, we take the coefficients. We're going to use the opposite of the n plus 2, so we use -2. And then we take the coefficients of our polynomial, and they go in the synthetic division. So 1n to the 4th, 10n cubed, 21n squared, a 6n, and a minus an 8. Wait a minute. Yeah. So then we add down. We're going to add this way. And we're going to multiply to get our next addition problem. So add the 1 down, multiply by -2. Add down, we get 8. Multiply by -2, we get -16. Add these two down, we get 5. Multiply by -2, we get -10. Add here, we get minus a 4. Multiply, and we get +8. And then we get 0. And this equals 0. Therefore, 3 little circle dots like that means therefore, n plus 2 is a factor. Really, we've done what the problem, at this point, we've done what the problem asked. It just asked, is it a factor? And we said yes, because we got 0 at the end, because there's no remainder. When we divided by n plus 2, there's no remainder. It is a factor. But from there, we could continue, and this is just a good practice now because we're going to need to do this later. Say, okay, n plus 2 times, reduce the exponent by 1, so 1n cubed plus 8n squared plus 5n minus a 4. And that's our new function. These are the same. If we were to multiply back, we should get what we started with here. We should really do one where it's not a factor. All of them have been factors so far. Let's do this one. P. So is p plus 5 a factor of p to the 4th plus 6p cubed plus 11p squared plus 29p minus a 13? And at some point soon, it's going to be useful to start taking guesses. Like, do we think p plus 5 is going to divide into this? It's going to start be useful to take guesses. So we're using -5, 1p to the 4th, 6p cubed, 11p squared, 29p, and a -13. So we're just going to add down and multiply diagonally. So I add the 1 to 0 and I get 1. Multiply by -5. Add, we get 1 again. 6 minus 5 is 1. Times -5. Add, we get 6. Multiply, we get -30. This makes a -1. 29 minus 30 makes a -1. Multiply, we get positive 5, and we're left with a negative 8. This does not equal 0. Our remainder is not 0. It is not 0. Therefore, p plus 5 is not a factor of that function. Can't be divided, 13 can't be divided by 5, so it's not going to be a factor. Okay, I think that's all I want to do today. We have 30 minutes, so you should use that time to work on the homework assignment. Okay. So yeah, we'll work on the homework.